Okay, hi, it's Miss Millsbury here, and today we're going to talk about dividing polynomials again. We're going to compare what you learned about long division last class, and then we're going to learn kind of the shorthand way called synthetic division, and some of you are going to like this a lot better, but I'm going to do a side-by-side comparison so you can kind of see where the synthetic division comes from. So this says find the quotient of, and we're taking 2x squared minus 3x minus 9, and we're dividing by x minus 3. Okay, so remember that process from last class. We're going to look at our divisor and say x times what would give me 2x squared. So x times 2x, so let me switch colors here. So 2x is going to be the first part of my quotient, and then we're going to do 2x times this divisor. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. And then we're going to subtract this. So remember, you can either do a subtract the whole thing, or you can go change your signs in this line to make sure you're really subtracting. 2x squared cancels, negative 3, it ends up adding 6, so I'm going to get 3x, bring down my minus 9, and do the process again. So look at your divisor, x goes into 3x 3 times, x times 3 is 3x, 3 times negative 3 is negative 9, and so this looks like it's going to divide evenly. I get a remainder of 0. And my quotient is 2x plus 3. No remainder. Okay, so for synthetic division, it's going to look weird at first, but it's an easier process because it doesn't include any of the variables. So for synthetic division, we're going to set it up with kind of a big L shape. And here at the top of the L, we're going to use the coefficients of our dividend, of what's getting divided. So I'm starting with 2x squared, so I just need the 2, minus 3x, so negative 3, minus 9, so negative 9. So this represents the coefficients of that quadratic expression. And then on the outside, we need to put what x equals. So notice the problem gave us a factor. And so to find the x, or the root that corresponds with, we would have to set it equal to 0. So x equals 3 is the actual 0 root or solution, and that's what we want on the outside of synthetic division. Okay, so that's our setup. So out here, if you want to make a note, we need to use a 0, not just the factor. The first step is always the same. We bring the first coefficient straight down, and now we actually do similar math to long division. We multiply, 3 times 2 is 6. I put that underneath my next coefficient, and I get to add straight down. Negative 3 plus 6 is 3. And then I go back out to the outside number. 3 times 3 is 9. I put that under my next coefficient. I add straight down and get 0. This last value here will always be your remainder. And these two numbers are the coefficients of your quotient. So when we get 2 and 3, that means our answer, it went down in degree. We started with x squared. We divided by something with x. So now my answer is just going to be 2x plus 3. And so we're going to practice this. And that would be our final answer. So really, it's doing the same math for us, right? I still got this 6, -3, and 6 we're combining here in synthetic, just like they did in long division. -9 and 9 combined as well, but it leaves out all the variables, and the signs are a little bit easier. So because we end up changing the sign at the beginning when we solve for the 0, you don't have to subtract along the way, you always get to add. So let's do it again so that we can get more familiar with it. Okay, so the next one says I have something cubic. So I'm taking x cubed, so I'm going to put a 1, minus x squared, so -1, plus 4x, and minus 10, so -10. And then my factor is x plus 2, so set it equal to 0. X equals -2. That's the 0 that I use outside of my synthetic division. And then the process is always the same. Bring your first coefficient straight down. -2 times 1 is -2, and we add straight down. -1 plus -2 is -3. Now go back out to your outside number. -2 times -3 is 6. That goes underneath my next coefficient. 4 plus 6 is 10. -2 times 10 is -20. Add straight down, and I get -30. This last number is always the remainder. So let's make sense of our answer. Because it started with x cubed, and we were dividing by x, the degree goes down by 1. X cubed divided by an x means this is 1x squared. You don't have to write the 1. And then the terms are going to go in order. So this is minus 3x, a positive 10, and our remainder is negative. So I'm going to put minus 30 out of, and then go look for your divisor. We were dividing by x plus 2, and so that's my final answer and how I would write it if I had a remainder. I'm going to use this 1 as part of my box for boxing the answer. And there we go. Okay, let's do it again. Let's get more familiar with the process. Okay, I have something cubic again divided by something with x. If you're watching this video outside of class, you might want to pause the video and try it and then check. So 1, 5, -7, and 2. Set your factor equal to 0. So x equals 2 is what I'm going to use outside my synthetic division. Bring your first coefficient straight down, and then we get to the fun part. 2 times 1 is 2. Add straight down to get 7. 2 times 7 is 14. Add straight down to get 7. 2 times 7 again is 14. Add straight down to get 16. So I have a remainder of 16. And of course, now let's make sense of our answer. This is not your answer. This is just the shortcut process to help you divide these two polynomials. So since it was cubic divided by an x, it's going to go down in degree to become x squared plus 7x plus 7, and then a positive 16 remaining out of the x minus 2 that we were dividing by. Now, one thing to notice, so far every single problem has been a linear divisor. We've been dividing by something linear, and that's how synthetic division works. It only works with linear divisors. So you might ask yourself, why did we even learn long division? It's so much more difficult. Well, you have to do long division if I asked you to divide by x squared or by something cubic. But if it's linear, we can use synthetic division. So we'll work on that more as the unit goes. Okay, the next couple have something unique about them. So of course, we've done a couple normal examples, now we've got to change it up a bit. Okay, so I can see this one has the 4th degree, quartic. And so I'm going to start with -2, then -1. Now this has a missing term. So since this is missing the x squared term, we have to put a 0 placeholder in that x squared spot. Otherwise, we're going to end up with the incorrect amount of numbers at the end. So x to the 4th, x cubed, there's no x squared, 4x, and -5. I'm going to set this equal to 0. So the x value I'm using is -1. Bring down your -2, and here we go. -1 times -2 is 2. Add straight down to get 1. -1 times 1 is -1. Add straight down to get -1. -1 times -1 is +1. Add straight down. -1 times 5 is -5. So this does have a remainder of -10. And then let's make sense of our answer. So same logic here. Since it was x to the 4th degree 4, dividing by an x is going to bring that degree down 1. So it's going to be -2x cubed now, plus 1x squared, minus 1x, oops, that 1 wasn't necessary, plus 5, and then I have a -10 remaining out of the x plus 1 that I was dividing by. Oops, sorry. So these are the coefficients of my quotient, and the degree has gone down by 1. Okay. D. So I said the next two were unique. This one doesn't have any missing terms. It's just cubed, squared, x, 1 constant. But notice in my factor, it's not just x plus something or x minus. It's 2x minus 1. So let's look at how that makes the problem different. Setup, still the same. I need the coefficients. Nothing was missing. And now for my 0, I'm going to set this equal to 0. So I add 1, and I have 2x equals 1. And so I'm actually going to get a 0 of a half. And so that's what I'm going to use outside of my synthetic division. I promise it's still not bad. But I'm going to bring a 6 straight down. And I'm going to do this process. Half of 6 is 3. Add straight down. Half of 10 is 5. Add straight down. Half of 8 is 4. Add straight down. Now, I have an issue. So the answer right now looks like it should be 6x squared plus 10x plus 8 with my remainder. However, if you're going to check yourself, right, think about when you divide, your answer multiplied by what you were dividing by should give you the original. And there's no way that 6 times 2 is going to give me 6. Where all the other ones had worked. If we did the x squared times x would give us x cubed, and so on. So if we have a fraction here, we have to divide all the coefficients by that denominator. So basically, our answer is going to be twice as big as it should be. So if I divide all of these by 2, I'm actually getting 3x squared plus 5x plus 4. I don't have to divide my remainder though. My remainder is going to be the same without dividing. And then 2x minus 1. So that's what you can do anytime there's a coefficient with x in your divisor. If you would rather do long division because you think you're going to forget to divide by 2 at the end or divide by that denominator, then more power to you. Okay, on the back we have a couple of applications. Well, maybe not applications exactly. But one thing that can be cool about synthetic division, it says use synthetic division to evaluate the following functions at the given value. So A has a cubic function and it says find f of 2. So over to the side, I'm going to go the algebra 1 route. What is this problem really asking us to do? It's saying, hey, plug in 2 for every x. Okay. Okay, so as I simplify this, I have to do my exponents first. 2 cubed is 8, so this is 5 times 8. 2 squared is 4, so this is 3 times 4. Minus 2 plus 7. So 40 plus 12, so 52. Minus 2, so 50. Plus 7, 57. Okay, well, what I want us to do, we're going to do synthetic division with this problem. 5, 3, negative 1, 7, none of the terms are missing here. And then think about, I'm not giving you a factor here, I'm giving you an actual x value of 2 that you would have plugged in for x in algebra 1. So I'm going to say x I know is 2. Let's do synthetic division and see where we find this 57. So bring your 5 straight down. 2 times 5 is 10. Add straight down. 2 times 13 is 26. Add straight down. 2 times 25 is 50. Add straight down. Our remainder is actually the same value as if we plug in 2 for the function. So there is a theorem, and don't have flashbacks to geometry, but there is a theorem, it's actually called the remainder theorem, and we're going to use it again, abbreviating theorem there, but the remainder theorem basically says if a function is divided by x minus, I'm going to put r, like a root. So if we have a function and we're dividing it by some factor, then plugging in that number to the function, it's going to equal the same as the remainder. So the big takeaway here is that we are looking for the remainder when we are asked to evaluate a function at a value. And so when your teacher is looking, or when I'm grading your paper, if you do it the algebra 1 way, you're not going to get the points for showing me that you can use synthetic division and doing it the way the problem says. And honestly, this math should be easier anyway. So let's try another one. We're given an x value of 4. And this problem looks short, right? It's a trinomial, but it's cubic. So be careful. It's missing an x squared. So negative 3x cubed, there's no x squared, 40x, and 35. And then the x value of 4. And then let's do it. Bring negative 3 down. 4 times negative 3 is negative 12. Add straight down. 4 times negative 12 is negative 48. 4 times negative 8 is negative 32. Nice. So the remainder is 3. And while I did not do a good job on this last one, bringing it all together, so the expectation also is that you answer the question. If you just stop here, you're not going to get full credit because you didn't explain to your teacher that you understand that f of 4 is 3. So same thing up here. I had written f of 2 is 57 over here, but I really needed to be specific and say f of 2 equals 57 and show that it's not the whole process, but that I understand the remainder is the solution here. Okay, our last type of problem, and actually the reason that we've been learning these methods. So, last unit we talked about how to graph our polynomial functions, their end behavior, their roots, and we hadn't really talked about how do we do all the factoring required if something's not really nicely factorable. And so these methods of division help us take a quadratic, a cubic, a quartic function, and put it in factored form. So 3 says determine all the factors of this function, given that one of them is x minus 4. Okay, so we could do long division, but that's not the point today. So I'm going to go ahead and use synthetic division to help me get started. I know the x value is going to be 4 when I set that factor equal to 0. I then have my coefficients of 1, -6, 5, and 12. Let's bring the 1 straight down and multiply, add straight down. 4 times -2 is -8, add straight down. 4 times -3 is -12. Nice, so this divides evenly with a remainder of 0. It was cubic, so now it's decreased in degree to be 1x squared minus 2x minus 3. And then it said determine all factors. So I want to know, can we now factor this expression? Yeah, we sure can. It's a trinomial, it's quadratic, so think about, we don't need to do a long process for this one. I know x squared would factor into x times x, and then to multiply to -3, but add to be -2, I would need -3 and +1. So this original function was cubic, so I just found that 2 of its factors, x minus 3 and x plus 1, now it needs a third factor because it was cubic, and that factor was given to us at the beginning. So basically, synthetic division helps us take something cubic, turn it into something quadratic that we're able to factor further, and then I could even ask you to go sketch a graph. We have 3 roots, 3, -1, 4. We can use the end behavior to see the left side is going to point down, the right side would point up. But again, not the point of this unit, just trying to tie it back to why we're doing this anyway. Okay, so you could pause the video and try this one, but I'm going to work through it just so you have a complete notes. Let's see, I'm glancing at it. It looks like none of the terms are missing. It goes cubed, squared, x, constant. Set that factor equal to 0, so I'm using an x value of -5. I write the x equals, I know I kind of awkwardly write it to the side, just to make sure that it's like a way to check myself. Did I actually solve for x? Because sometimes it's easy to glance and put just a 5 there. All right, multiply and add straight down. Multiply again, add straight down. -5 times 8 is -40. So y'all, if you're asked to do this on an assessment, to give all the factors, it means that it's going to divide evenly. So if you don't get to divide evenly, then something went wrong in the process. Okay, so now it's lowered in degree from cubic to quadratic. And factored form, let's see, the x squared comes from x times x. The 8 comes from 4 times 2, and to add to be negative 6, let's make them both negative. And then our third factor is x plus 5 that was provided. Okay, and we're going to keep working on both synthetic and long division and then their applications as well. Hopefully this video was helpful.